Welcome to the DIY Honda Garage channel. Today we will be discussing a specific diagnostic trouble code, DTC P0102, which indicates a low voltage issue in the mass airflow sensor circuit for the Honda Accord models from 2012 to 2017. The mass airflow (MAF) sensor is crucial for measuring the amount of air entering the engine, which aids in determining the correct air-fuel mixture needed for optimal engine performance. This sensor utilizes a hot wire technology where airflow cools an electrically heated wire, and the Powertrain Control Module, PCM, analyzes the sensor's output to assess airflow levels. If the output drops below a specified threshold, in this case 0.10 volts or less for an extended period, the PCM will register this anomaly, turn on the malfunction indicator light, MIL, and store this code. Understanding this DTC is vital for successful troubleshooting and restoration of vehicle performance. Ensuring that air intake measurements are accurate and that engine function remains efficient. To prevent future occurrences of DTC P0102, regular maintenance of the mass airflow sensor and associated systems is advisable. Periodically cleaning the MAF sensor can help maintain its accuracy. Use specialized MAF sensor cleaner to avoid damaging the sensitive components. Additionally, ensure that the air intake and air filter systems are kept clear of contaminants. Inspecting and replacing air filters as needed will prevent debris from reaching the MAF sensor, thus prolonging its operational lifespan. Implementing these preventive measures helps secure optimal engine performance and fuel efficiency over time. In conclusion, the mass airflow sensor is vital for ensuring the proper air-fuel mixture in Honda Accords from 2012 to 2017. The DTC P0102 indicates a critical low voltage issue requiring careful troubleshooting. Each step, from inspecting wiring and testing voltage to replacing the MAF sensor, builds upon a clear strategy to restore engine function. Emphasizing the significance of preventive maintenance can help minimize future issues associated with airflow measurement inaccuracies. By understanding the components involved and implementing rigorous diagnostic processes, vehicle performance is maintained at its best, promoting a smoother and more efficient driving experience for Honda Accord owners. The mass airflow sensor is located on the intake air passage of the vehicle, directly interfacing with the air entering the engine. This sensor plays a pivotal role in measuring the volume of incoming air to inform the engine control module precisely how much fuel to inject for combustion. The sensor operates using hot wire technology, where a wire is heated electrically. As air flows past this wire, it cools it, and the PCM measures the current necessary to maintain the wire's temperature. When the airflow changes, the detected current also varies, which allows the PCM to calculate the amount of air for proper engine operation. If there's a malfunction, like a low voltage output from the MAF sensor, it can lead to poor engine performance, reduced fuel efficiency, or increased emissions due to an incorrect air-fuel mixture being fed into the combustion chamber. Several issues can lead to the P0102 DTC being triggered. First, a short circuit in the MAF sensor VGP line to ground can disrupt the sensor's function, causing inaccurate airflow readings. Alternatively, if the VGP line is open, the current path necessary for the sensor to communicate with the PCM could be interrupted, preventing the MAF sensor from functioning correctly. A third potential cause could be an open in the power supply line of the sensor, which would mean the MAF sensor is unable to receive the voltage it needs to operate. Finally, a failure within the MAF sensor itself could result in permanent malfunction, and it's crucial to inspect and test the sensor component thoroughly. Each of these issues must be evaluated carefully to accurately pinpoint the fault causing this diagnostic trouble code. The symptoms associated with DTC P0102 can vary, but commonly include the illumination of the check engine light, also known as the malfunction indicator lamp, MIL. Drivers might experience poor acceleration, where the vehicle does not respond as expected to throttle input, leading to frustrating driving conditions. Additionally, a rough or unstable engine idle could occur, which often means that the engine is struggling to maintain a consistent idle speed due to incorrect air-fuel ratios caused by faulty readings from the MAF sensor. There may also be increased fuel consumption as the engine attempts to compensate for the inaccurate airflow measurement. Recognizing these symptoms early on allows for timely troubleshooting, which can lead to more efficient repairs and avoids further complications. The first step in troubleshooting DTC P0102 involves a visual inspection of the MAF sensor wiring. It's essential to check the wiring for any visible signs of wear, fraying, or damage. Look closely to determine if the MAF sensor VGP line has any shorts to ground or if there are any breaks in the circuit. Ensure that all connectors are securely fastened and look for any corrosion that might affect conductivity. If any wiring issues are detected, repairs should be made before proceeding with further diagnosis. Accurate handling of this wiring is crucial as it directly impacts the functionality of the MAF sensor and influences the PCM's ability to receive correct data. In the second troubleshooting step, use a multimeter to measure the voltage output of the MAF sensor while the engine is running. This provides confirmation of whether the sensor is providing an adequate voltage reading to the PCM. An expected reading should be well above the malfunction threshold of 0.10 volts. If the voltage is falling below this threshold, it reinforces the likelihood of a malfunctioning MAF sensor or associated wiring issues. Make sure the connections are secure before taking measurements, as loose connections can lead to erroneous readings. Document the voltage readings as they are essential in guiding the next steps in diagnosing the issue accurately. This measurement is critical as it directly reflects the operation and health of the mass airflow sensor. For the third troubleshooting step, focus on the connections to the powertrain control module, PCM. Inspect these connections thoroughly for any signs of corrosion, damage, or loose contacts. Given that the PCM relies on signals from the MAF sensor, any compromise in these connections could lead to poor performance or inaccurate readings being sent to the engine management system. Use a wiring diagram to ensure that the connections correspond correctly to the right terminals. If any faults are found, corrective actions must be taken. Ensuring that the connections are well maintained helps guarantee that the MAF sensor can communicate effectively with the PCM, facilitating overall engine performance. The fourth step involves testing the vehicle with a new or known good mass airflow sensor. Replacing the original MAF sensor with a new one allows for direct evaluation of whether the previous sensor was the cause of the DTC P0102. Observing voltage output with the new MAF sensor should yield values above the malfunction threshold if the sensor was at fault. After the installation, ensure that all connections are secured and the vehicle is started to monitor for the check engine light. If the light remains off and engine performance improves, it confirms that the new sensor resolved the issue. This step is essential for confirming the health and reliability of the MAF sensor's function within the overall system. Once repairs have been completed, it is important to clear the DTC using a scan tool to reset the engine control module. After clearing the code, take the vehicle for a test drive to validate that the problem has been successfully resolved. focus on evaluating the driving conditions that initially caused the DTC to set. Monitor engine performance, particularly during acceleration and idle, to identify if the check engine light reappears. If the DTC does not return after a few drive cycles under diverse conditions, it indicates that the repairs were effective, affirming the successful resolution of the issue. This final verification is crucial to confirm long-term reliability and functionality of the engine management system. Please like and subscribe to the channel. See you next time.